Notice at the top of the review are the formulas that we had throughout the chapter. They are not labeled, notice. So you need to know what formula is appropriate to use for what. Okay, so you don't need to memorize the formulas themselves, but you have to know when to apply the formulas. They may or may not appear in the same order on the actual test. So you need to know what the formulas look like in terms of recognizing when to use which one, but you don't need to have the formulas themselves memorized. So the first one is for an arithmetic sequence. The second one is for a geometric sequence. The third one is for an arithmetic series. The fourth one is for a geometric series. And the final one is for an infinite geometric series. Okay. So it has the A sub n on the left-hand side. Those are sequences. Those are to come up with terms in the list. When it's an S, those are series that we're finding the sum of all of those terms. If it has an R in it, it would have to be a geometric because R is a geometric thing. It's the ratio, and that happens in a geometric. If it has a D in it, that would be an arithmetic. And then the arithmetic series is just kind of maybe a little bit harder to recognize, but by a process of elimination, you could see, well, it doesn't have an R in it, so it's not going to be the geometric that way. Okay. So you do need to be able to recognize the formulas of what they do and when to use them, but you don't have to have them memorized. All right, so then our first type of question says, tell whether the sequence is arithmetic, geometric, or neither. This 108 is kind of weird. It should actually be up here with the negative on the previous line. The margins got a little messed up there. So, should get there. I'm going to over-erase them. All right, so then the first one, 7, 10, 13, 16, what is that doing? It's arithmetic. We're adding by 3.
Well, we have to explain why.
You don't have to explain why. You can just say which one it is or that it's not one. So since we're adding 3 there, that makes that an arithmetic. What about number 2?
Geometric.
Geometric. We're multiplying by 2. What about number 3?
9.
That one doesn't have one of our either addition or multiplication patterns throughout it, so that's just neither one. And what about number 4?
Geometric.
That's geometric. We're multiplying by -3 as we move through that one. Okay. So knowing what it means to be arithmetic, geometric, and then that it wouldn't be one of those two. So arithmetic, we're adding the same thing over and over. Geometric, we're multiplying by the same thing. Writing the first 6 terms of a sequence here. We're going to start by plugging in 1. You can use your A sub notation if you want to, or you can just calculate them and list them out as fine as well. A sub 1, I would plug in a 1 for n. And that gives me 0. A sub 2, I would plug in a 2. That gives me 3. A sub 3, I would plug in a 3. Gives me 8. A sub 4, plug in a 4 would give me 15. A sub 5, plug in a 5 would give me 24. And A sub 6, plug in a 6 would give me 35. So you can either list them out showing them in that notation, or if you just kind of handle the arithmetic in your head or on a calculator and you just give me the list of the numbers with commas, that's totally fine as well. Just kind of whatever's easiest for you in that way to process through those. Okay, go ahead and do number 6 and 7. All right, so for number 6, if I start by plugging in a 1, I would have 2 times 0. If I plug in a 2, I would have 4 times 1. If I plug in a 3, I would get 6 times 2. If I plug in a 4, I would get 8 times 3. If I plug in a 5, I would get 10 times 4. And if I plug in a 6, I would get 12 times 5. For number 7, this is one where really just listing by commas might be the easiest way. If we plug in a 1, we get negative 1. If we plug in a 2, we get negative 2. And so on. And so that's fine if you just list them with commas and you don't use the a sub number notation. But if it's easier for you to think about that notation because then you see what you're actually plugging into the formula, then that's fine. So it's just kind of a preference of what you need to be able to accomplish the problem. Questions on those? The next group of problems wants us to do 2 things. Find the next term and write the rule. And this is the explicit rule. Unless it specifically states or cursive, we want to do an explicit rule. So here we'll be using the formulas from the top of the page, applying the appropriate one. So the first thing we need to do is really determine what kind of a sequence is this. Are we adding by something or are we multiplying by something? So for number 8, what are we doing? Adding by 4. So our next term would be 24. And then if we're adding, this would be our arithmetic. So then the arithmetic formula is a sub n is a sub 1 plus n minus 1 times d. So then our formula would be a sub 1 is 8, n is our variable, and d is the common difference, which is 4, what we're adding. Don't leave it here. Always clean up your arithmetic formulas. So we're going to distribute that 4 through. And then combine like terms to get 4n plus 4. Questions? I'm going to go ahead and jump down to number 11. What are we doing on 11? Multiplying by 2. So if we multiply by 2 again, we get 32. Since we are multiplying through this list of numbers, that means this is going to be geometric. And our geometric sequence formula is a sub 1 times r to the n minus 1. So for this problem, a sub 1 is the first term, 2. R is the ratio, which is also 2 to the power of n minus 1. You cannot combine that 2 and 2 and make it a 4. There actually is one thing of arithmetic you could do since they have the same base. We learned a while back that when we have the same base, we can actually add the exponents together. So this is like 2 to the 1, and we could make this then if we add those exponents together, it would just be 2 to the n, but you don't need to do that, okay? But that would be the only way actually to arithmetically or algebraically simplify that. You cannot make it a 4 to the n minus 1, which students often want to do, okay? So my assumption is that you'll just leave it right where it is in that box, okay? And that's fine. Questions on applying the formulas for arithmetic or geometric? Okay, go ahead and try the other 4 problems in this section then. All right, so for number 9, that is an arithmetic. We are adding 3 each time there. So our next term would be 14. And then we apply the arithmetic formula with a first term of 2 and a common difference of 3, and then simplify that down. Number 10 is arithmetic. We're adding 10 each time, so our next term would be 60. Apply the arithmetic formula with a first term of 20 and a difference of 10, and then simplify that down. Number 12 is arithmetic as well, with a difference of -2. We're subtracting 2 as we move throughout, but we always want to think about what we're adding. So we're adding a -2. So our next term would be 2, and then when we apply our formula, we need to make sure our first term is 10 and our difference is a -2. We're adding a -2. So we distribute that through and combine like terms, being careful with the negatives there. Now remember, you can always check your formula too. If you try like plugging a 3 into it, you should get the third number in the list. And if you do, then your formula is working If it's not, then your formula isn't working. So you can always test it out that way by plugging a number in and making sure that you get the right number in the list that way. Number 13, we're multiplying by 1/3 each time. So our next one would be 1/243. Multiplying makes us a geometric. So we apply the geometric formula, and you can leave it right there where it is in the box. You cannot make it 1/9. You can't multiply those fractions together. You could, since they're the same base, combine them the way that we did and talked about back in number 11, but you don't have to do that. And you can only do that if they are both the same number. If it was different numbers, you couldn't actually combine them in any way then. So this is just kind of a special case in those two problems since they were the same number. Questions on any of those? Okay, next one's asked us to write a recursive rule for the sequence. In number 14, we're given an R value. What kind of a sequence is this then if it has an R value? A geometric. So a recursive rule must always have two parts to it. You need the first term, and you must state that, or at least box it in when it's written there. The fact that I gave it to you doesn't count unless you acknowledge it's there. So if you just want to put a box around it, that's fine. If you want to rewrite it, that's fine. But you need to do something to indicate that you know we need a starting term for a recursive. Then a recursive tells us what to do after that. So after we start at 3, if this is geometric, we're multiplying the previous number by this ratio. And the way we say previous number is a sub n minus 1. And we want to multiply that by our ratio of 0.2. So recursive rule always has two parts. Where do we start and what do we do after that? And after that we take our previous answer and we multiply it by the ratio if it's geometric.
That x times 0.2.
It's that x just means times. Yeah, so it's just a multiply. So you could use an x or an asterisk, or you could use like parentheses as well. It's just a multiply. Number 15 gives us a d value and a starting value. So if it has the d value there, what does that mean this is? An arithmetic. So we still need a starting value, which you either need to write or indicate you know is part of the answer by boxing it in. And then we need to know what do we do after that. And arithmetic means we're adding to the previous answer. So we're going to take previous answer, a sub n minus 1, and we are going to add to that the common difference of 4. So an arithmetic is created by always taking the last answer and adding to it, whatever that difference is. Number 16 just gives us a list of numbers, so we have to find our own pattern here. We still need to indicate where we start, so a sub 1 is 88. And what do we do after that? What's happening in this sequence? We're multiplying by a half or we're dividing by 2. So you could write it as a sub n minus 1 divided by 2, or you could write it as a sub n minus 1 times a half or 0.5. Either way is fine. Dividing by 2 or multiplying by a half is the same thing. We need to give our starting value, and then what we're doing after that. We're taking the previous one and either dividing it by 2 or multiplying it by a half. Questions on the recursive? Okay, so then we go into some sum problems here. We have our sigma notation. So we're going to be finding the sums of these different series. On the front of the test, you had some formulas for sums of either arithmetic or geometric. All of these will be arithmetic or geometric. So you need to recognize what kind of a rule do they look like. So number 17, what kind of a rule does that one look like? An arithmetic. A geometric will have an exponent in it. An arithmetic won't. So this is going to be our arithmetic. So we want our arithmetic formula then, which is S sub n is n a sub 1 plus a sub n over 2. What is n in this problem?
1.
How many terms are we working with?
1.
20. So we're starting at 1 and we're going to 20, so that's 20 terms we're working with. So n is 20. A sub 1. How do we find a sub 1? We plug in 1. So we take a 1 and plug it in and we get 5. A sub n, if n is 20, we find by plugging in 20. And that gives 43. Feel free to use a calculator. I plug it in chunks, so you can plug it in all in one piece if you're very careful with parentheses, so your calculator does order of operations right. But I would either type in the top or do the top of my head. 5 plus 43 is 48. Divide that by 2, you get 24. Multiply that by 20, and this thing becomes 480. Actually, let's skip 18. Let's do 19. 19 is what kind of a series? Geometric. You can tell it's geometric because it has that exponent in it. So when it's an exponential rule, that's going to be a geometric formula for us. Our geometric formula is S sub n is a sub 1 times 1 minus r to the n over 1 minus r. From the front of your paper, you don't need to have that memorized. You just need to know which formula to grab out and use for the problem. What's n in this problem? 5. We're starting at 1 and we're going to 5. So 1, 2, 3, 4, 5 is 5 terms we're working with. A sub 1, how do I find that? Plug in the 1. Whatever's on the bottom we plug in. So that gives me 3. 1 minus r. How do I know what r is? R is always whatever has the exponent on it. Whatever the base of that exponent is always going to be our r value. So r is 3. We said n is 5. And again, we need to be really careful when we go to plug this in the calculator. I plug in the top, so I would do 1 minus 3 to the power of 5, hit enter. Divide that by, I do the bottom in my head, so negative 2. Divide by negative 2, hit enter. Multiply by 3, hit enter. And that gives us our total of 363. I'm going to jump down now and look at 21 here together as well. What kind of a rule is 21? Geometric. So we're going to use the same one we did last time. What's n in this problem? 4. We're starting at 1 on the bottom, going to 4. So 1, 2, 3, 4. We're working with 4 terms. A sub 1, we find by plugging in the bottom. So that gives 1/4. 1 minus r is always the base of the exponent, so that's 1/4. And it's 4. When you plug this into the calculator, you need to be extremely careful with parentheses. Even if you plug it in pieces, every time you plug in a 1/4, you need to put parentheses around it. Now, since it's 1/4, you could use a 0.25, and that would be fine, and then you can avoid the fraction that way. But if it were like 1/3, you cannot round that off. It will create error in the problem. So you need to actually use 1/3 then, and you would need to put parentheses around it every time you plug it in. So I would type in 1 minus parentheses around 1/4 to the power of 4, hit enter. Divide by, I can still do that bottom subtraction in my head and say it's 3/4. So I would do divided by, in parentheses, 3/4 and hit enter. And then multiply by, in parentheses, 1/4. Every time you're typing a fraction into your calculator, since there isn't like a fraction button on the graphing calculators, you put parentheses around it to let your calculator know that that's 1 unit together. When we do that, the calculator is going to want to give you a decimal on this, and that is 0.33. 3 to round it off, or as a fraction. Your calculator can turn things back into fractions. If you go to that math menu, you have an option to turn stuff back to fractions. It's 85 over 256. I'm okay with the decimal as the final answer, but go to at least a few places. Don't make a big broad rounding on that. Go to at least a few places there. Okay, go ahead and try number 18 and 20. All right, so for 18, that's an arithmetic. There's no exponents in that rule there, so that's our arithmetic formula. So the same formula as number 17. We're working from n is 1 to n is 15, so that's 15 terms for our n value. To get a sub 1, we plug in the bottom, that gives 6. To get a sub n, we plug in the top, which gives negative 8. And when we calculate that out, we get a total of negative 15. Number 20 is geometric, so we use the same formula as we did in 19 and 21 there. To find a sub 1, we plug in the 1 on the bottom and we get 8. Our ratio is always whatever is the base of the exponent, whatever has the exponent on it, so that's 8 also. When we plug that into the calculator, we get 37,448. In geometric, series can get very large very fast when we have a big multiplier. So multiplying by 8 is going to make this series grow extremely fast. Questions on any of those series problems?
So how did you get a to the n
In number 18, I got a to the n by plugging the 15 in for n, and that gives negative 8. So we get a sub 1 by plugging in the bottom, and we get a sub n by plugging in the top. To the formula right within the sigma. Other questions on those series? Right, number 22 asks us to find the sum of, so we want to use one of our sum formulas, the first 25 terms of the arithmetic sequence. So it tells us which formula to use there. 25 terms is our n value, that's how many we're going. Our arithmetic formula is S sub n is n times a sub 1 plus a sub n over 2. So we are told we're working with our first 25 terms. So n is 25. What's a sub 1? 3, because we're given the list of numbers there. The first number on the list is 3. A sub n would be the 25th term, but this list only goes out to the 4th term. It only goes out to the 12th. So if we wanted to know the 25th term, we either need to continue this on, which is a little bit annoying to go all the way up to 25, or we need to use our arithmetic sequence formula. Our arithmetic sequence formula will allow us to find any term within the sequence. So if we want to find the 25th term, we're going to be working with n as 25. A sub 1 is 3. We're looking for the 25th term. And what is the common difference of the sequence? 3. So that gives 3 plus 24 times 3, which is 75. We can plug that into our sum formula now, and then calculate that to get a total of 975. Okay, so this one required both the arithmetic sum formula and the arithmetic sequence formula. We're looking for a sum, so we knew we had to use the sum formula, but within that we needed to know what the 25th term was, and we didn't. So then we needed to know what the sequence rule was to be able to get that 25th term. Questions on that problem? The next one asks for an infinite geometric. That was the final formula from the front of your test. First, is it a legitimate thing to even do? Because it could just be that there is no sum to an infinite series. I mean, if you're adding up stuff forever, it could be that it just actually just keeps adding up to infinity itself. So is it legitimate to find the sum of this series? And how can we tell?
It keeps getting smaller.
The numbers are getting smaller and smaller and smaller. Our ratio is smaller than 1. So since these numbers are getting smaller, eventually it's going to be like we're adding 0, and it won't make a difference to it. So it is legitimate to find a sum here. A sub 1 is our first term, which is 12. What is the ratio? A half or 0.5? So that gives us 12 over 0.5 or half, which is 24. We can kind of check that by starting to add up some terms. So 12 plus 6 is 18. 3 more makes 21. 1 more makes 21 and a half. And this difference is going to keep getting smaller and smaller and smaller. So forever after that, we're only going to add up to another 1.5 more than that to get to 24. 24. Write the series with summation or sigma notation. We can always choose to start wherever we want, but it's typically convenient to start at n as 1. Then we need to come up with a rule for the inside of this. What kind of a series is that? What is it doing term to term? We're adding as we move throughout. So an adding series is an arithmetic. So we're going to use our arithmetic formula. A sub 1 is 8. And the common difference is 8. Distribute to clean it up. And combine like terms, and that just turns into 8n. Which we can check and make sure that actually works. If we plug in 1, we do get 8. If we plug in 2, we get 16. If we plug in, etc., we get on through. So then the last thing we need is what number goes at top. The most common wrong answer on the top is to put a 40. Okay? The top does tell us where we end, but it doesn't tell us what the term value is where we end, but the term's place where we end. So what would I need to plug in to get a 40?
5.
A 5. So a 5 goes on top. Okay? The top and the bottom should both be n values. The bottom one should be the n value that gives us the first number in the list, and the top number should be the n value that gives us the last number in the list.